All right. Hello, everyone. I'm your host, Anthony Yang, the committee chair in career development for AYLUS and a sophomore at Watson Hills Regional High School. AYLUS stands for the Alliance of Youth Leaders in the United States. We are a student-run nonprofit organization dedicated to the advancement of our communities, which range from our own houses to all across the United States. If you're interested in joining, feel free to check out the AYLUS website that I'll post in the chat. Today, we are with our speaker, Dr. Xiaotao Wu, who is affiliated with JP Morgan Asset and Wealth Management Technology as an executive director responsible for building analytics systems for portfolio construction and risk management. Prior to JP Morgan, he held R&D positions at Bloomberg and Fidelity. Before joining the financial industry, he was a research scientist at Avaya Labs Research with 12 granted patents and 50+ peer-reviewed publications. Dr. Wu earned his PhD in computer science from Columbia University and a bachelor's degree of computer science from Tsinghua University, China. Welcome, Dr. Wu. Thank you for being here today. Okay.
Thanks, Anthony.
Yeah. So I think we can start off with the first question. Dr. Wu, could you please give the audience a brief intro of your career journey?
Sure. So first of all, hello everyone. It's an honor to be invited by AYLUS to share my experience as a computer engineer. So I think like many of you have already started to learn something about programming. For example, in your school, you have Java and Python class. So you already know something about computer science, right? So I basically started to learn computer science at the same age as you, right? Basically, I started when I got into college, about 18. And then at that time, I first get in touch with computer, right? And then I got my bachelor degree and a master's degree in artificial intelligence when I was in China. Then I came to US, and the first year I did something in computer graphics. And then I changed to computer networks. So basically I try to mention different fields in computer science, computer science is a very broad area, right? And then when I do the research in Columbia University, specifically on internet communications, right? I got my PhD, and then going to basically in my intern, I go into AT&T Research Lab, and then after graduation, I go into Avaya Labs Research, specifically focus on internet communication. Then around 2012, I jumped into the financial industry, building financial products for portfolio managers, risk managers, and so on. So I would say for my career journey in computer science, the first half more on computer science, and the second half more on computer engineering. So one on research, one on build products. That's basically roughly my my journey. So Anthony, back to you.
Yeah, that's great. So for computer science, what do you enjoy about it?
That's a good question. So basically, for computer science, I think two things. I would say first thing, this field is very exciting. It's a very fast growth field. You can always find things new, and and you're never going to get bored. The field that push you to learn. Always you need to learn new things. Always have new technologies and fun things for you to play with, right? And certainly the other thing is I enjoy coding. I think some of you may already start coding, and I hope you can find the beauty of coding. When you write a nice piece of code, that you can really enjoy that. So maybe I can share some of my experience as computer engineer to further elaborate why I enjoy that, right? So honestly speaking, when I was at your age, 16 or 17 years old, I have no idea about computing. Okay, so only when I got to college, I started to get in touch with computer. It's different from you guys. You basically have computer in your daily life. Play games, iPhone, iPad, all kind of thing, right? In my age, I don't have that luxury. But then when I got into college, at the first year, I think I remember we don't have personal computer. We have something called mini computer. Even though it's called mini, it's huge, basically like a bookcase, right? and it's extremely slow compared to the current nowadays computer, right? It's kind of millions times slower than the current, like, your personal computer. However, like in this industry, I mean, basically in the semiconductor industry, something called Moore's law. I don't know whether you heard about it. So basically that means your computer or some electronic devices, can be like every 1.5 or 2 years, can be like twice faster than before. So this kind of exponential effect is very powerful. You can think like after 20, 30 years, really we have computer millions times faster than before, right? And this kind of speed, enable a lot of things, right? That's why, I mean, that's maybe one of the reasons make this field like so exciting. Think about if you can do things like, twice like faster, like every 2 years, right? And then like after 20 years, you can like millions times faster. You're really going to be Superman. Like, everything can be possible, right? So really like in this field, like many things like 20 or 30 years before, it's impossible. Now it's achievable, especially in the machine learning and artificial intelligence. You have heard about that. A lot of things, it's theoretical like 20 years before, but now it's really already a reality, right? You can have self-driving cars and so on. So that's why, I feel this field, because it's growing fast, it's exciting. You can always get new things, right? Then the other thing is, let's talk about the programming, right? I think like when you start to learn Java or Python, maybe at the beginning you kind of feel kind of boring, right? Because you need to remember some things. What's a variable? I mean, print hello world. I mean, hello world, right? Why bother, right? You just print it, right? It's it's not fun. But once you starting to know more and more programming language, right? You can consider that to be something like your English or Chinese or those kind of your human language. You can write good article. The same thing. You can write in plain, boring things or articles, and you can write in well organized with good writing style, with a very beautiful sentence. It's very enjoyable for people to read, right? Those kind of article. Same thing for programming language, right? Basically, for the same kind of project or piece of code, you can do that in a buggy, like lengthy or slow way. You can also do that in an elegant way. Like for example, sometimes when we interview people, right? So the same question, some people write like 40, 50 lines of code and very slow, and you can say another bug. You can have also some good programmer write the same thing. 5 lines code, very elegant, get good result and very fast. So those things, you like when you do the programming, you put your intellectual efforts, you basically think about it. And when you achieve that, it's like, when you're in a young age, right, you try to solve a puzzle and you try to find a very nice way to solve a puzzle. You're going to have that kind of wow effect, right? Basically, that's really something you can enjoy. That's something, I mean, I would say, I can just think about 2 main things I can enjoy about the field. All right.
Yeah, that's great. Like, I definitely can relate to that because I've actually done some computer science, and when something goes right, it just feels really good. And so, like, regarding computer science, could you give us like I know you gave us like a slight introduction. So, like, what kind of talents do you need to do well in computer science? Like mathematics, like what type of talents do you need?
I would say like I know like people join this talk, right? A lot of you guys interested in STEM, right? I would say like anyone who has good at STEM, basically, when you do STEM, right, really like logical thinking. You have good logical thinking. That's the basic ability, and you're good. I mean, as a tech, I worked in Bloomberg like for about 2 years. We have like junior developers really from different majors, from people in chemistry, physics, and so on. They provide some training, like 6 months. I remember like 6 months training program, right? You have some basic coding. You go into that training program, and you got trained. You can start, really to build like industry kind of level of coding, right? So I would say math maybe, but it's not kind of required. But logical thinking is definitely important because you need to write, think about, you need to think of a way the computer can, follow your way, right? You need to make a good like code structure and so on, right? That's a requirement. And certainly, math can definitely help. All those kind of computer things, the math you can consider if you want to go into higher level. And then you really go into some philosophical thinking and the proof and so on, right? Especially in the so-called computer science, in the science area, right? Those math skills definitely helpful, right? You have formal definition and the proof of your theory, right? And especially in algorithm and so on, math greatly helped. Okay. And for typical IT, it's not very required, but it's helpful, right? And then the other thing regarding the talents is I would say like not specific for computer science, but more like in general, right? Communication skill, right? So the reason I mentioned like for nowadays, like 20 years or 30 years ago, it's important, but not as important as now. The reason is the computer system gets so big and so complex, right? Usually one person cannot like handle a big project. You have to collaborate with the other. Okay, that means from time to time you need to like tell the other what's your idea, and if you think you're right, you have to convince the other, and also you have to do this in a very effective way to handle the communication. I mean, some communication based in computer science, we have, we may have different styles of communication. For example, we have some control flow, data flow. Basically, you can draw some flow to show your idea, in trying to put your logical thinking, rationalize your thinking, right? Then to make a good project. So I would say that's kind of talent, and that kind of things you need to have to get into the industry, to be a good developer.
Yeah, so like communication with others and teamwork and stuff like that. So could you also give us like a brief description of like the biggest challenges that students with a computer science major will face as they work in that industry later on?
Computer science major in the industry. Let me think about this. Basically, when you start in school, right, you're like, especially in the bachelor years, right, you basically learn about some basics. Maybe I can give you something about like what the computer science about, right? Then we can talk about the challenges. So you can consider computer science in general. We try to make a computer or computer system better, right? And then like using that methodology of technologies to build a real world project, right? And then to do this, right, like we have like computer hardware and computer software, right? You're going to learn, if you're going to computer science major, you're going to learn both, because that's kind of basics, right? And in the computer hardware, like, you're going to say, I would say like when you're trying to get some idea about computer hardware, the good thing is you open the box. I mean, certainly with permission from your parents, right? You open the box, you say what's going on there, and I would say even better, you can try to assemble your own computer. That's not that hard. You can buy components and put things together, then how to do that, right? Then like the other thing is really about computer software. That's now, I mean, basically we handle that in our daily life. Right. So then like you think about in the computer software, just all different kinds of sub areas. Let's think about a very simple thing. You do that in your daily life, right? For example, you have your iPhone, right? You face your face yourself and got to log in, basically have face recognition. And then you're trying to say like Siri, tell me the weather today, right? Then for that one, once you talk about it, they're going to be, your iPhone going to pick up the voice recognition, switch to text, and from text going to do something, called natural language processing, right? You're going to let the computer knows you're talking about the weather, then going to send your request like a query to the network, going to the server side. There are computer networks involved. Right. Then at the remote server side, there may be some sensor collecting text like weather information saved in the database. You have database, you query it, you got the result sent back, right? Then from there, the Siri going to tell you, right? It's going to text to speech, another thing, right? All those things, for the computer to understand you, you're going to have something like artificial intelligence and machine learning, to make computers smart enough to understand you, right? Then to put all these things together, you have iPhone, Android, this operating system. And when you do the coding, you build something, make computer understandable, this compiler. And then to hook all these things together, we have something called software engineering, basically, how we make things organized, right? There's a very broad area, right? So for computer science major, when you first get into the college, you're going to, if I remember, at least when I was in college, we learn all those kind of basics. Just touch it, not go in depth, right? So different area. And then you need to, it's kind of overwhelmed because there's so many things. Even though computer science history is less than 100 years, but still, it grows fast. It's accumulated a lot of knowledge. And the other thing is the knowledge keep updating. Okay, so you're going to have a lot of things to learn. And also computer science is so-called applied science, right? So that means you're going to have, I don't know, maybe you have the same thing, right? You're going to have very heavy projects. You need to do the real thing to code, right? And if I remember, when I was in master or PhD here, right? You many times do the project, in the midnight or even longer, take a very long time to finish the project. I don't know whether you guys already, maybe you do your coursework the same thing here in your high school, right? But when you do the coding, really, because you don't want to interrupt your thinking process, sometimes you really sit there for a long time. That's going to be challenging for you, right? And then, certainly, if you want to do advanced degree, there's an additional challenge. Basically, you got the basics, then you pick up field to go in depth, right? That one is really going to the challenge, the research, and sometimes you got confusing, you got puzzled, how you're going to find a way. Those kind of innovations, another challenge, you're going to face later. I would say, college, a lot of knowledge you need to handle. Need to mention there's other things, related to computer science, like math, something you also need to learn and so on.
Yeah, so there's just a lot when in computer science, maybe a difficult challenge that might be a little bit hard to overcome. And I've definitely experienced that. And so getting into financial engineering, could you give us a reason on why you got into financial engineering? And could you tell us what it's like to work as a financial engineer?
Financial engineering. So as I mentioned, right, basically, in my work, right, the first half, I'm going to more on the research side. Then second half on the engineering part, right? The difference is, it's just in my humble opinion, the science part is more on research, more computer itself. Engineering, more about build something. It's not about good or bad. It's different kind of working style, different kind of lifestyle, and different kind of thinking process, right? It's just it's around 2012. I just feel I want to do something real instead of doing the POC and writing papers. I started to build the real world projects, right? And then I get into the financial industry, right? And build products, for the financial world. Okay, so then by the way, what's the next part of your question? How I get into financial engineering? Then
could you tell us what it's like to work as a financial engineer?
Okay, what next work? I would say the financial industry is so broad, right? In different companies, and there are different kind of working style. Like Bloomberg and Fidelity and JP Morgan. I didn't into the hedge fund industry, but I have some friends there. Is the working style is very different. Let's say for example in Bloomberg, it's more like technical company. You have software engineering teams. Usually, the people in the software engineering team, they talk to each other. Not much chance for the software engineering talk to the business side. maybe they have some people collect you with the business requirements, but in most of the time, you just internally, it's more about engineering problem, right? Then in the JP Morgan, like in my team, basically we face the portfolio managers, quant researchers day by day, right? So in that case, the communication is very different, right? It's the team like consists of different people. Like when you build a project, you're going to have portfolio managers to help testing your products, quant research to build, provide methodologies, statistical models to you, right? And sometimes middle office to help you, to coordinate the efforts. And certainly you're going to construct your own team to build the products, right? And then also we involve infrastructure team and some other team, So we kind of form people from different area to build products. So I would say in the JP Morgan, the communication and the collaboration is kind of more important. But certainly, from engineering perspective, right? We also need to think about, as I mentioned, right, to build a nice and beautiful code is important. We want to so-called like strategic solution, by the way, in computer science, where you also have something called architecture design and so on, right? So those things is really from engineering perspective, you need to think about. Okay, I know some people also in the hedge fund is different working style. They certainly care about like performance and some more statistics and those kind of things. It's totally different working style.
Yeah. So in the financial industry, so like what kind of advanced degrees do people usually have in that industry? And like what type of degree do you need to get into it?
So to this one, I would say degree doesn't matter too much, honestly speaking, because it's really about your knowledge and ability. Right? We have people from different kind of major, right? We have people from like chemistry, from physics. They have, as I said, like we need to have a good logic thinking. All those kind of STEM like degree, right? To some extent, really can prove your logic thinking ability, right? And then like certainly we need people to have the software development ability, but for that one, certainly you got degree is definitely very, very helpful, right? But nowadays I think that computer science is different from maybe different from chemistry, physics. All those kind of we have so many resources online, right? For example, if you want to do some like big data and so on, right? For those things, you don't have to buy a supercomputer, right? You just have a moderated computer at home. You can go into AWS, basically Amazon cloud. You have all the things, all the resources you need. We have an open source community. If you have questions, you can ask, and just so many people will help you, right? So then, like think about how you want to build your knowledge and ability. That's very important. If you are interested in that, you can always get resource. So that's why I trying to share with you like regarding the degree, right? On the other hand, like when we do the hiring process and so on, we look at people's like degree. Also, we trying to say what kind of projects he had to work on, right? The open source community, there's so many projects you can contribute if you are interested in that. You can easily find something you can do.
Yeah. So could you also like give us a description of like what kind of characteristics is the financial engineering industry looking for, and what does success look like in your position?
The characteristics. Let's put it here. So first thing, like maybe I trying to say that the word financial engineering a little bit confused because financial engineering, some word in the financial industry means some other things. Means you use a statistical model to have the different financial products to create new products, right? So basically, like basically we call ourselves like information technology or fintech or those kind of things, right? So in the financial industry, and for the characteristics, still it's really about the talents you have. We talked before, logical thinking, super important, because you want to rationalize, your decision, and also for you do the computer coding, a lot of logical thinking there, right? And communication, right? Those things, I would say, still the skills you need to have. Okay, and then like to be success. Put it this way, that's really a hard question, I would say, because the definition of success is very different. Like you guys, your parents, and some other people going to really everyone have different definition about success, right? So I would say I just like from engineer perspective, to have some like my thinking about success, right? So basically success is it's a kind of feeling, something you feel about yourself or others feel about you. Okay, so then like from an engineer perspective, I would consider it's not that hard. It's kind of easy. Basically, think about you build some project, it's impactful, some others used. You already think your project is a success, right? To some degree, and you write a nice piece of code. It's so beautiful. You like it. It's like in English, write a good article. You can enjoy yourself. It's also a success, right? But this kind of self-sufficient way, right? To have good success, I would say, you certainly need to give yourself a high standard. For a set, like for the same work, you can do that in a noisy way, write kind of a lengthy, buggy code. You can also do a nice code that really need you to put efforts. So it's easy in some extent, you don't have to like looking for big, huge success, right? It's hard because if you want high standards, you need to put efforts, right? And then actually all those small success, maybe, when you build a small project, you build some library and those things, like in my project, right? When I just got into JP Morgan, I built a computation library. It's used by, many other people, many other groups and different projects, right? That to me is kind of success. And those kind of small success together, you can start to build a successful system, right? It means you have all different things together. It have bigger impact. Those things you can consider to be a success, and to have people recognize you, to like acknowledge your achievement. Maybe you got a promotion, got income. That's considered to be a like the result of your your self-sufficient way, right? So that's also a success. So that's basically my understanding, from engineer perspective.
Yeah, so having high goals and achieving those goals would be also like that definition of success.
Yeah.
So about that JP Morgan project you were working on, could you describe it a little bit more and like the process and how you were able to achieve what you wanted to?
Okay, the project certainly like in the JP Morgan project, I wouldn't say it's that very complicated. Certainly we still need to put a lot of efforts, right? So usually we're trying to get requirements from our business partners. in my specific projects, we also need to work together with quant research, to get idea, methodology, and so on, right? Then we need to think about, how to architecture the project. So by the way, like if you guys interested in the computer science, it's much more than programming, because in computer, when you're trying to think about how you compose things together, you're going to have small piece things, whether it's composable, and also because the computer science, it grows so fast. New technologies, new thinkings keep evolving, right? You want to make your project can be changed. Okay, doesn't mean it's different. Like you build a whole dam, use for 50, 100 years, right? You build something, and you expect that need to be changed in 2 or 3 years, and you want to make that to be changeable. Okay, so that's something I would say. Going back to your question about success, right? Regarding projects, I would consider, for the project, those success is a process. It's not a state. You want to make your project have the potential to be, to keep the success. That means you want to adapt to new technology. You always try to learn new things. And then you keep thinking about refactoring your project. So in the JP Morgan, when I build some project, for example, the library I mentioned before, 5 years ago, right? It's used at that time. I kind of think, okay, that's good. People are using it. I kind of saying, okay, the coding style, I'm kind of satisfied, at least for myself, right? But nowadays, I look back, well, something can be changed. We want to make that support and going to cloud and so on, because at that time, JP Morgan doesn't support public cloud yet, right? Sometimes when you do the design, it's limited by your overall environmental context. But when things change, you have to adapt to that. And at the beginning of your design, you want to make your things adaptive. So that's something, you may learn something from school, but usually in your bachelor years, you do the the basic things, but you want to keep your mind open. Like what you learned, it's truth at that time, it's going to be changed. Because it's a fast growing field, always trying to open to new things. So that's I would say what I trying to build project in JP Morgan.
Yeah, so like being open-minded and adapting to your situation and your product to your project to make it better and have it serve more use and purpose. And yeah, so could you also tell us how you overcame a challenging situation in your career?
A challenging situation. I think we came from the the high level view and maybe lower level view, right? So usually you call yourself a technologist, right? Basically, you're going to have face some technical problem or challenge, right? And when I do some coding, for example, I face some performance issue. I know that in the computer science there are all kinds of different languages. Maybe later on I can share you some video. Anthony, when you're trying to ask me for a talk, I immediately thought about that interesting video regarding computer language. So at that time I used language called Q. KTB. It's a language, very interesting language, I would say. But it has some limitations. So when you're facing that one, you need to have broader knowledge and open mind. Not limited to the things you're working on. You're used for that moment. You need to think about some other way. For example, in that case, using C++ to write extension for that language to overcome some limitations, right? And then that's really going to be very detailed level to handle the challenge. You're always going to open mind and always trying to find a different way, right? Then in a higher level, it's really the project or multiple team environment, right? So we always facing tight timeline, right? So for those things, really as I said, from a computer science perspective, it's growing. Your project need to keep changing, right? But for changing, you need to take efforts. You need to educate your business partner or your the other side, who use your software to tell them, okay, I built something, and that's something good for now, but we are always trying to schedule time to enhance it. We cannot just keep that there, right? And those time and efforts, we need to ask people, we need to educate people, right? We need to budget that. That's another challenge. You're trying to educate people, trying to convince people. That's about communication. The communication challenge is always there.
Yeah.
Okay.
So we have a question from Jill. She says, could you give some advice on career plans? 1, doing pure computer research, computer science research. 2, find a good job in a decent company. And 3, start my own business using my web development skills and business ideas.
All right, let's do one by one, right? First one is about the curriculum, right?
Yeah, the first question is advice on doing pure computer science research.
Pure computer science research. Okay, so I would say when you do the pure computer science research, the first thing you need to find out what's your interest field. As I mentioned, right? For example, in the example I just mentioned, there's a computer networks, database, natural language processing, computer graphics, computer vision, right? And some other operating system, compiler, networks, right? when you first into college, you may touch base on each of them. You need to find out what you are interested in. So if you like interested in, for example, the very nice graphic looking and to build some nice game or something like that, right? You can try to choose computer graphics, and for that one, there's another research and those things on that area, right? If you want to, for example, as nowadays, right, it's very hot about artificial intelligence and machine learning, right? For that part, certainly it's not just about computer science, but also about statistics and math. That requires another math skill, by the way. So it's better to, take courses about math, statistics, and have good understanding about the fundamental thing about machine learning and artificial intelligence, right? And getting familiar with different kind of packages and so on, right? Then if you want to do the database, there's another like interesting thing to learn, right? Really about the transaction and so on. So you're going to get into that space, right? Then the other thing is, even if you learn some, for example, artificial intelligence, like machine learning, when you're trying to apply that, for example, as we talk about natural language processing, right? To have computer understand what you talked about, right? For those things, you're going to learn something about linguistics and those kind of things, right? So try to find your interest, definitely the first step, right? Try to find about all the related fields, because for those things, some domain knowledge needed. Okay, you need to try to find classes or courses related to your field. Then the other thing is, you really need to read papers if you don't want to do research. As I said, like for communication in the research, it's different from communication engineering. In research, people have papers, conferences, and so on. You need to know what other people are thinking, okay? And also for the research and in the specific field, it's about innovation. You have to create new things. If you want to create new things, you don't want to reinvent well. You need to know what others are doing, right? And to enhance that or think about new ideas. So that's something I can think of regarding the research and so on. And the second question is about the.
It's about advice on finding a good job in a decent company.
Okay, good job in decent company. So think about which company you're going to, right? For example, for Google, Facebook, and Amazon. I mean, you certainly know about all those like the online questions, right? Those kind of coding questions. That's for junior developer. That's quite important, I would say. And for that one, certainly you want to get familiar with computer algorithms and practice, I would say. Because like like for those like tech companies, it's very competitive, I would say, in terms of pay rate and lifestyle and so on. It's very attractive to young guys, right? And then like for those things, I have several young people from my team. They join those companies, and certainly they spend a lot of time to practice those coding questions. I mean, same thing for you guys, right? If you want to go there, right? If you want to go into the financial industry, I mean, it really depends on your interest. If you're interested in financial knowledge and also have the ability for the software development, right? I think financial industry, fintech, and those things is a good choice, right? So for those one, you need a combination, financial knowledge, some math, I would say is very helpful, especially statistics, right? Then the computer science skill. Okay.
Yeah, and the final question from Jill is advice on starting their own business using their own web development skills and business ideas.
Cool. So basically, that's, I would say, very interesting question, because when you're trying to start a new company, certainly, I always encourage people to do something, new and but on the other hand, I always trying to say, it's hard, right? The thing is, you need to think about one thing is, the reason going to the engineering thing is, in the real world project, there's so many things to think about in addition to your coding, okay? So in the engineering field, you have a lot of like steps for decision making, okay? For that one, I would say, it's just based on, my like limited project management, experience. I would say a lot of trade-offs when you're trying to make decision. So for that one, not just about web development or the basic idea, it's really about engineering detail. You need to think about the whole thing as a system. Okay, for the system design, you need to think about what if, like for example, 100 users using website, what's going to do? And if tomorrow going to be 1,000 users, and if your project is very popular, in 2 or 3 days or 1 or 2 months, going to be millions of users, can you handle that? And can you handle that in a technical way? Or is any other like so-called operational and those kind of things you need to think about? So it's more about system engineering. I would say, to do that, some kind of fundamental regarding software engineering and so on, you try to get some knowledge about that. That's going to be helpful. And then regarding the web development, right? So usually, like when we do our project, we do have like graphical designer and so on, because it's really not about you make something work. You want to make something work nicely, right? If you have to think about the project, for example, the iPad, right? Those kind of tablets, right? Like really like Microsoft started before Apple, I would say, right? But Apple's iPad because so popular, right? It's really engineering detail and those kind of things going to be important. So when you're trying to start your company and trying to build a nice product, a lot of detail you need to work out.
Yeah, so like important like details and really just stuff like that. And going back to like teamwork and communication, like how do you feel about working in computer science with the technologists around you?
First thing I would say, like in computer science, we have a culture of collaboration, right? So the reason I say that is we built so many tools to help us. I don't know if you guys use like if you already done something for the open source community, right? There's GitHub, there's version control things, right? And like for example for wiki, it's really about like knowledge sharing. GitHub Git is really about the version controlling, right? We have the agile like methodology, for software development, right? Regarding how team work together, right? And no need to say like open source community, so many people can help you to solve problems, right? So those are like the culture built in for the computer science folks, I would say, right? Then inside the team, especially in the big company like JP Morgan, we're always trying to like at least like inside my team, we're trying to encourage like people help each other and sharing the knowledge. On the other hand, I would say the collaboration is one is about helping. The other certainly another thing is about like what we call like protocol or standards or API. Basically, when you're trying to talk to each other, right? Once you learn the computer networks, you can have this kind of habit. When you have two parties try to talk to each other, you define the protocol. You want to define very clearly what the interface should be. So that's another way, like in the computer science, how we handle communication, in a tactical way. So it's maybe different from other fields, but we keep doing that, in our everyday's work. And we also have a community, for example, you guys use like, for example, Zoom, right? It's really internet communication, right? If you go into some like organization called IETF, Internet Engineering Task Force, it defines all the protocols for our network communication, right? So define the protocol. Those are the communication things we're trying to handle. And then like within team, when we collaborate, we also define protocols, APIs, and clearly define that.
Yeah. So more in like the open source software, could you like explain like a little bit of that? Like just the regular open source software and like how that works and how like people are able to collaborate with each other.
Okay, so basically you think about some projects, right? In the open source, basically, first thing is like open source, the contributor, right? the one time they certainly contribute for free. The other thing is they certainly expect those kind of software can still make profits, right? So like in open source community, there are different licenses, right? People may use that for free, but once you have for some license, right? When you use that for profit, you still need to pay the fee or claim, make some claims, right? So open source is not like every open source for free. That's one thing we want to be clear, right? And certainly there's some like BSD, Apache license, Berkeley license, so on. You can read those kinds of license terms, right? And then in the community, usually, you're going to have some coordinator, right? Like the main guy, or few guys to control your commits. Right now I think a lot of open source are using so-called GitHub. I don't know whether you guys heard about that. That kind of online kind of like a repository for your code, and people collaborate and commit code, right? Then for open source, they have a so-called commissioner. Those guys actively maintain the open source. You can always try to contribute, make new features, fixing bugs. And when you commit code, those commissioners are going to review your code and to handle the so-called check-in, to make your code to be official. Okay. And then thirdly, for some open source, finally become company and so on. For example, if you can consider Linux, right, it's kind of open source, right? But we do have different companies to provide services, right? The people can still make profits and make big profits from the open source. Some open source really becomes, like going to IPO and going to make big money, right? So they can provide services for the open source, like software and so on, because they are domain expertise.
Yeah. Okay. So we also have another question. The question is, could you give some advice on how to get started in computer science and finance for someone in high school who has very little experience with either? Also on college selection.
All right. So it's just like my personal opinion, right? If you, first thing is, try to learn some coding. That's always the basics, no matter what you do. Finally, you're going to do some coding, right? Either Java, Python. Right now I'm more like Python. It's a kind of script language. For the beginner, it's kind of easier to pick up because when you type something, you can immediately see the result. You don't need to compile and so on. And also Python has so many libraries and so on, right? So also, in my opinion, Python is a very elegant language. You can enjoy some coding using Python. All right. And then in the financial area, I know that in your high school, you have macro and micro, right? Those are some fundamental knowledge you certainly need to learn. And then from there, additional to that, I would say some statistics will be helpful if you are interested in if you are like STEM major, interested to build some models, that can be helpful. So for those things, a starting point, trying to build some simple thing at the beginning, right? For example, like trying to get some stock price and like trying to show that, drawing some graph, like in Python. You can always find an example. The other thing I like to say is, in the computer science learning, usually like it is helpful to learn by example. There's so many sample code you can download, play with that. That's going to give you some touchable ideas and things you can show and to show yourself what's going on, right? That's something can be helpful as a starting point. Okay, then regarding the college learning?
College selection.
College selection. There's certainly all the rankings regarding the computer science regarding those schools, right? For example, MIT, Princeton. For some school, I would say more on more theory based, like Princeton. For computer science, I would say if you have good math and so on. And for some schools, certainly more practical, right? It's more about doing enough like real project and so on, right? So certainly those top schools is always good, right? And for example, Stanford, MIT, Princeton, Carnegie Mellon, and those kind of top schools, always good. And the other thing is you can find out is for those different schools, they are going to be stronger in some specific areas, right? Like Stanford, certainly in artificial intelligence, and also MIT, right? So artificial intelligence is quite strong, right? Regarding some computer theory, I would say like Princeton is quite strong in computer theory, right? And you can, all those information you can easily find online, right?
Yeah, so we also have another question. The question is, could you please elaborate the future job market on artificial intelligence, natural language processing? What are the core skills needed specifically in these areas, which are differentiated from computer science in general? And how would you see your computer science background to be utilized in the financial world?
All right, cool. Several questions here. First thing is about the natural language processing and artificial intelligence. So I would say that's it's very hot field right now, right? You can consider for this field is it's interesting. It's been hot around like 70s, and then like going down for several years. I mean, for 10, 20 years, because the computation power not picked up. And that time you don't have computer networks like what we have now, and the computation power, like CPU power, is not that powerful, even though we already have the theory at that time. Some of the artificial intelligence models, it's already been there. And nowadays, the internet, right? So have parallel computing, cloud computing, and then all the computation power really make that very, very powerful for now. So I would say if you are interested in natural language processing, you certainly want to know something about the linguistics, and the statistics is very important. Okay, and right now we have so many tools like TensorFlow, all those kind of tools. You already have that. You can certainly take some online courses to as a starting point, right? I said like computer science is applied science. You have to get your hands dirty. Play those things, try those things, start from simple, about like understand what's a tensor and how you build a simple model, and play with some things and say what the result you're going to get. All those things are open source software. You can download, install, and play with that, right? Regarding the foundation part, if you want to build a system, right? I would say, because that requires a lot of data, database, some basic database thing you need to know, right? And you need to download things, to have enough computation power. Going to cloud computing and those things, get some basics would be helpful, right? And then certainly coding, I would say like Python coding is something you need to learn.
Yeah. So like further on that question, like what are the core skills like specifically in like this artificial intelligence area that are different from computer science in general?
It's it's highly related. I would say it's different. Artificial intelligence, you can consider that to be to some extent a sub area in the computer science, if we put this way, right? Certainly it has its own kind of specialty there, right? Because it requires a lot of math knowledge there, right? And it requires something, for example, for natural language processing and computer vision, and voice to text, right? All those things, we all require some like artificial intelligence, skills there, right? So artificial intelligence is really some methodology, regarding, like, for example, deep learning and those things, regarding you understand about statistical model, and then apply some domain-specific thing to the things you're research on, right? The vision, you basically will handle all those computer graphs and so on, and handle different machine learning model to recognize your image, right? Like, for example, if you go into specific medical image, that's more specific, technique need to be used, right? Then you're going to like voice recognition. It's a different kind of domain knowledge, but still using computer like machine learning technology there, right? Then like all kinds of models and so on need to be used. So I wouldn't see that very different from the general computer science. Because if you want to do that, you still need to all the basics, network, database, coding. It's better for you to understand, computer architecture to build like efficient skills, right? So then you can go into more focus on specific research, just about machine learning.
Yeah, and the third part of the question is, how would you see your computer science background be utilized in the financial world?
Okay, so computer science background, I would say there's a network, database, software engineering, and at least those things is heavily used, right? When we do the financial engineering, build the products, think about like certainly the coding skill and so on. All right, software engineering is quite important. Basically, as I said, like, we're trying to build some successful products that can adaptive to new technologies, right? You need to follow the, for example, if you want search, you can search. Like in the software engineering, there's some principle, like solid principle, object-oriented, design and so on. Those things is quite important, right? And then like the computer networks, because if you trying to say that we have some called microservice, and those things in the financial world, it's a broad area. You have multiple components, how they're going to compete with each other, right? And then how you're going to architecture those things, right? That requires you understanding some network protocol. So have different components communicate with each other. Then certainly a lot of data, right? Then you're going to have the knowledge about database, right? And in database, there's a lot of different things, right? Regarding NoSQL database, transactional, basically those kinds of relational database and so on. Those things, I would say, when you in your like college, you're going to learn that. Some fundamental things. Certainly, like the things you learn in school, in bachelor, is not enough to be applied to the real world, right? So I would say like when you in your college, trying to do some project, open source or something, some kind of real project, so you can get an idea, what the real world going to be like. It's different from the course projects.
Yeah, so this is I'll end it here. So now that we have finished, hopefully you all have learned something about the financial engineering industry and how to get into it. Even though people have been asking questions, we'll open it up to you guys for any further questions you'd like to ask regarding this topic. So please type your questions in the chat or use the raise hand feature so we know who is asking the questions. We'll just wait maybe 1 or 2 minutes if there's any extra questions. If not, then, oh, okay, we have a question from Ching.
Yes, Dr. Wu, just a quick question. I know some kids are interested in computer science initially, and then was overwhelmed by the complexity. So is any chance they will still go back, find the new interest in this area, after first, kind of be overwhelmed?
So overwhelmed, you mean it's kind of too complex to resolve?
Yeah, too difficult to to learn.
Regarding the students learning the problem, or regarding like how the computer science field try to solve the problem?
I think generally computer science field.
Okay, so I think like for example, artificial intelligence is a very good example, right? So you think about like in the 80s, 90s, in that field, in that time, right? We have the theory, for example, the backward propagation and those kind of theory, and some of the like models for artificial intelligence, it's been there, right? But the computation power, the network speed, and those things is not there, right? So it's been passed, right? But I think the exciting thing about computer science is the speed grows so fast. Something's impossible, and once you got the computation power, people start, keep doing research, keep trying to find a new way, and then take advantage of this improved computation ability. And then you go back and say, okay, now like 20 years or 10 years ago, it's not possible, right? It's really achievable and can achieved in a better way and can achieve the results. So that's why, like in our projects, something, even though like previous is solvable, but not being solved in a nice way, we need to keep refactoring. Right now, for example, I have a project like 10 or 15 years old. Think about 10, 15 years old, that technology and nowadays technology is very different. We're going to rebuild it in a better way.
Thank you.
Yeah, and we also have a question from Amy. The question is, do you have any advice for getting internships as a college student with relatively little experience other than school projects or research?
So I would say like, you already know like in the first year, second year, it's going to be hard, but still, I think like the GPU is quite important, right? So basically you try to get an internship, think about like for the people going to interview you or look at your resume, right? You're going to have your GPU, people know you're a good student. And then regarding the course projects, right? You can show a bit what you did, right? And then the other thing is, you can certainly always try to find a chance to contribute to like open source, to your like school's research project. Try to find a professor, you already can find some topics for you. So you're like in the industry, right? When we're trying to get intern, one thing is intern is not about really to achieve something. It's also kind of training program. We're trying to find like good candidates for the future, and we want to make sure this candidate is really trainable and really have a good characteristics, so we can put efforts there, right? So if you want to, you can show that you can certainly improve your chance.
Yeah, and we also have another question. The question is, question on online course, good online course resource. So like a recommendation on a good intro level computer science online course.
For that one, I may need to do some research myself to find it. I think that usually those like good university, MIT open course, Stanford open course, right? Those things you can certainly that kind of have a good credit. Certainly for those kind of university open course, that's going to be a good like starting point, right? Then certainly for some I would say like some certificate course is helpful, but may not be that helpful. You can take it, and some other things, if you go into YouTube and you can check people's review and so on, those things can be another way you can find the resource.
Yeah, and the last question for today will be, what is the market share for SQL, NoSQL, and new SQL?
So basically, I don't know exactly market share there, but don't think about the kind of fight each other. They are really complementary to each other. Okay, it's really like they are not going to one replace the other. Still like SQL as a transactional database and those kind of relational database, right? And have the things on strict transactional and so on, right? They still have the good advantage, especially in the financial area, right? So don't think like one going to replace the other. They are not. It's really like when we design project, we're going to find what's our best choice. Even though like NoSQL and those things is new, and people like it's a hot area, and people like trying to pay more attention to that. But when you design real world project, you need to think about the maturity, safety, and whether you really handle those kind of relational information and so on. So sorry, I don't have the exact answer about the market share, but I just want to try and say they are complementary to each other.
Yeah. Okay, so that's going to be it. Thank you everyone for coming. Thank you, Dr. Wu, for speaking on this topic. Hope everyone has a good rest of their day.
Thank you.